Hello, this is Dr. Amrupriya, Associate Professor Tripoli, Rohini College of Engineering and Technology, Palkulam. We are discussing about the subject protection and switchgear for the regulation 2017, and we are now discussing about electromagnetic relays. So what is an electromagnetic relay? These are the relays which are operated by the principle of electromagnetism. Modern electrical protection relays are mainly microprocessor based, but still the electromagnetic relay holds their places. It will take much longer time to replace all the electromagnetic relays to microprocessor based static relays. Now let us discuss about the electromagnetic relay principle. It is operating based upon the magnitude measurement, ratio measurement, and the comparison. The principle is working based on the attractor armature type or induction disc type, induction cup type, in balanced beam type, moving coil type, and polarized moving ion type relays, and the respective types are being discussed below. First, let us take the attraction armature type relay. Actually, this is the most simple one in construction as well as principle. These types of electromagnetic relays can be utilized as either magnitude relay or ratio relay. These relays are employed as auxiliary relay, control relay, overcurrent, undercurrent, over voltage, under voltage, and impedance measuring relays. Looking at this device, we can see the hinged armature and plunger type constructions are the most commonly used for these types of relays. Among the two constructional design, hinged armature type is more common. We know that the force experienced by the armature can be expressed as an equation which is based on the current square value, that is the square of the current of armature coil, considering constants like K and then the restraining force K dash. The threshold condition, at the threshold condition for relay operation, Ki square is equal to K dash. From this equation, we can understand that when the operating force is being equated by the restraining force, at that time there is no problem. If suppose the operating force is greater when compared to the restraining force, then obviously the system will be working in a better condition, and if suppose the restraining force is greater than the operating force, then the system will be subjected to the fault condition. It can be understood that it is subjected to the fault condition, and the relay has to operate itself in order to trip the circuit using the circuit breaker. This is the condition here. This relay is essentially a simple electromagnetic relay and a hinged plunger. Whenever the coil becomes energized, the plunger being attracted towards the core of the coil. Some NONC, that is the normally open and normally closed contacts, are arranged mechanically with this plunger. NO contacts have become closed and NC contacts become open at the end of the plunger movement. Normally, attraction type relay is a DC operated relay. The contacts are so arranged that after relay it is operated, when a relay is operated, the contacts cannot return to their original positions even after the armature is de-energized. After relay operation, this type of electromagnetic relays are reset manually. You can see their construction. It's okay, good and simple in construction. Next type is the induction disc type relay. Every induction disc type relay works on the principle of Ferrari's principle. This principle says a torque is produced by two-phase displaced fluxes, which is proportional to the product of their magnitude and the phase displacement between them. Obviously, the torque T is equal to, it is proportional to phi1 phi2 into sine theta. So while coming under the disc type relay operation, it acts on the same principle as that of an ammeter, voltmeter, the meters. The deflecting torque is produced by the eddy currents in an aluminum or copper disc by the flux on an AC electromagnet, and here the aluminum disc is placed between the poles of an AC magnet, which produces an alternating flux lagging from I by a small angle. As this flux links with the disc, there must be an induced EMF E2 in the disc, lagging behind the flux by 90 degrees. As the disc is purely resistive, The induced current in the disk I2 will be in phase with E2. As a result, as the angle between I and I2 is 90 degree, the net torque produced in that case is 0. So T is equal to 0. In order to obtain the torque, it is necessary to produce a rotating field. So we are in need of an part or a copper ring which induces it. So there we go for a pole shading method of producing the torque. Here actually the two fluxes are divided into two parts, and this can be considered as a phi is equal to total flux. So phi is equal to phi 1 plus phi 2. As one portion of the pole is shaded by the copper ring, there will be an induced current in the shade ring which will produce another flux of I2 in the shaded pole. So the resultant flux of shaded pole will be the vector sum of both. And now T is equal to K into phi 1 phi 2 into sin theta. There are mainly three types of shape of rotating disk available. While considering this, for high speed operation, this type of relay can be used relevantly and reliably. The induction disk type FED is an negative sequence filter which can be used as negative sequence protection device for the alternators. The third type is the induction cup type relay. Here it also works on the same principle as that of induction type relay, but here the condition is for very high speed operation along with the polarizing or adder of a differential winding is required here. Generally 4 pole and 8 pole design are available. The number of poles depend upon the number of windings to be accommodated. The induction type disk relay is a design we can consider for high speed operations. The pole system is designed to give maximum torque per kVA input. In a 4-pole unit, almost all the eddy currents induced in the cup by one pair of poles appear directly under the other pair of poles, so that the torque per VA is about 3 times as that of induction disk type relay. So obviously this is suited as a directional or phase comparison units. This is because besides their sensitivity, this type of relay have steady non-vibrating torque, and their parasitic torque due to current or voltage alone are very small. This directional relay or power relays, in this case the torque is directly proportional to phi k into E into I into cos of phi minus theta, or k into phi 1 into phi 2 into sin 90 minus theta. So this is how the torque is getting produced. Accordingly, it produces a maximum torque. When system angle theta is equal to 0 degree or 30 degree or 45 degree or 60 degree, the former is known as a power relays, as they produce maximum torque when theta is equal to 0 degrees, and the latter one is known as the directional relays. They are used for directional discrimination in protective schemes under fault conditions. Thank you.